Hey guys, what's up? So here's the speaker V Sathish from SJBIT. So today we're going to see the program. You'll give the coordinates in BCD and we will set the processor will set the cursor position on the respective position which you give on the input. So here we are. So dot model small, you know about it, dot stack, you know about it, dot data here. You'll initialize message 1, this is the string, message 2, this is the string, message 3, this is string. So we are initializing two variables, row and column, with defined byte. So here is the macro program to display the message. Now code starts from here. So move ax act data, move ds ax, this message 1 that will display this, enter the row number by going to the macro function and then call reads. So we have written one procedure called reads and we'll get to that later. Initially we'll see up this from. So after you get the you'll get the value in AL register. So from AL you will store it in row and then again you'll display the message to enter the column number. So again you'll call the read function. So again it will go to reads procedure, which is right here in front of you, and then you will get the whatever you give the input, it will be stored in AL register, and that AL will be given to call and it is moved to column, and then it displays a message 3, that is press any key to terminate. So after that you will create one video interrupt, so that you will create one screen. But if you check out these two rows, which is initially in before programs we used to write our own default value, but in this program we need to set the cursor position according to the user, right? So we are getting the input from the user as row and column, and we are using that values here to set the cursor position, so that whatever value you give here, it will generate the screen according to it and it will set the position. So after that move AH, 08H in 21H, it's an interrupt till you give it's interrupt for the user. So it halts here, the processor halts here and does not go for any other execution. So it waits for the user to press any key, and then if you press any key, then it executes for the next instruction. So if you press any key, after that it will goes to move AH, 4CH in 21H, which terminates the program. So here we are. So what does the read procedures does? So initially we'll move AH, 01H in 21H. It gets the input from the user and the input will be stored in AL register. So from what we do here is we'll clear all the junk values which is present in the upper nibble. So we are AND with 0FH. So F will retain the values of AL and 0 will clear the contents of the upper nibble. So then after clearing it up, we are moving the AL value to BL. After that move AH, 01H in 21H, again we are getting the input from the user. So that input will be stored in again to AL. So again we are doing the same step. After that what we are doing here is we are getting back the value before value to AH now. So now if you can see here, if you type the row value as something like 24, so initially you will type 2, so that will be stored in AL register as 02, and this 0 will be AND with 0F, and this any junk value which is here will be cleared to 0 and 2 will be retained. So then after that what happens is we will move to BL is equal to 02. After that again we will get input. So if we give 4, so that will store in 04 now. After that we are going to move BL to AH, so AH will be having 02, right? So AH is 02 and AL is 04. So we need to combine these two to one single AL register so that we can use it as a single value. So in order to do this, we are using AAD, that is ASCII adjust before division. So what it does here is it is like packing the elements from AX to AL. That does the AAD. So actually what it does is initially it will take AH value, it will multiply by 10 and it will add with AL. So now check it out with this example. So AH value is 02. So if you multiply by 10, it becomes 20. After that AL is 4. So if you add with 4, so it gives the value as 24. So as you can see, the given value will be converted into one single value and it is stored in AL now. So AL contains 24 and it returns. So after returning, it goes to here rows and columns whatever whenever we call, and that current position will be moved to row and column and displays the output. So that's the program is all about. So thanks for watching. We'll catch up in next video. Bye bye.